Welcome to the Crazy Hat Chemist. So another video here on bonding. Bam! So today we are going to be determining the number of sigma and the number of pi bonds. Okay, so let's do this here. So we're going to determine the number of sigma and pi bonds in the molecule of H2. Okay, so the first thing that we need to do is we need to draw a valid Lewis dot structure. We're going to draw a valid Lewis dot structure every single time we try to determine the number of sigma and pi bonds. So right here is a valid Lewis dot structure of hydrogen, the molecule of hydrogen. Okay, so how many sigma and how many pi bonds are there? Well, there is a single bond here between the two hydrogen atoms. So that is one sigma bond, and there are 0 or no pi bonds. Okay, because pi bonds only occur in double and triple bonds. All right, so that means that this kind of looks like this. This is not really the hydrogen molecule whatsoever. These black things are carbons and the white things are hydrogens, but this is a sigma bond. It's a head-to-head overlap of atomic orbitals, either S's, P's, or S and P combination. So this is a sigma bond. It's a single bond. All right. So the next one here is we're going to determine the number of sigma and the number of pi bonds in the molecule of oxygen. So the first thing that we have to do for each one of these is draw the Lewis dot structure. And here is the Lewis dot structure for oxygen. So oxygen has a double bond. So how many sigma, how many pi? So you first have to have a sigma first, and then since there's a double bond, then you have a single pi. So you should see that there's one sigma and one pi. And again, this is not oxygen, but the idea here is the following. This is the sigma bond that I'm holding on to here, and that is the single bond. That occurs first. And then thereafter that, if there are multiple bonds, which a double bond is a multiple bond, then right here in the purple and the pink is the pi bond that is above and below the plane of the sigma bond. The sigma bond is a head-to-head overlap, and the pi bond is above and below the plane of the sigma bond. Okay? Hopefully that works well for you. Then the next one is we're going to determine the number of sigma and pi bonds in the molecule of nitrogen. Notice that I've picked all diatomic molecules here, but it doesn't need to be diatomic molecules. These are just very simple structures in which you can do. So here is the Lewis structure for the nitrogen molecule. Okay, so this has a triple bond. So the first thing that is formed is a sigma bond, and then there is multiple bonds in this. That is, there's a triple bond. So there are how many pi bonds? So you have one sigma and two pi. And showing that right here is the following. Again, this is not nitrogen because the black ones are carbons and the white things are hydrogen. So an entirely different molecule. However, I'm just showing the number of sigma and pi bonds. So right here, again, I'm holding on to, it's kind of hard to hold on to here in the middle, but I'm holding on to the sigma bond, which is a head-to-head overlap of atomic orbitals, head-to-head overlap, and that's within the plane. Now, above the plane and below the plane of the sigma bond, and you can see that, above the plane and below the plane of the sigma bond are 1, 2 pi bonds. Okay, so 1 and 2 pi bonds. So again, double and triple bonds inhibit rotation around the axis of that bond. So hopefully you should be able to have determined the number of sigma and the pi bonds here. Okay, all right, so we're going to do some more. Okay, so we're going to determine the number of sigma and pi bonds in this acetylsalicylic acid, which is aspirin. So here's the structure of acetylsalicylic acid, which is aspirin. And now we're going to count the number of sigma bonds. So we're looking for the number of single bonds here. So let's count here together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So how many sigma bonds are there? There are 20 sigma bonds. Now, the next thing we're going to do is we're going to count up the number of pi bonds. Now, the number of pi bonds are just counting multiple bonds. So I need to look for either double or triple bonds. This molecule that I've chosen does not have any triple bonds, but it certainly has double bonds. So let's count up the double bonds. So that's 1, that's 2, that's 3, that's 4, that's 5. So how many pi bonds? There are 5 pi bonds. Okay, so you should be able to determine the number of sigma bonds, the number of pi bonds, and the total number of bonds of sigma and pi within a molecule. I am the Crazy Hat Chemist, and I got another crazy hat for you here today, and here we go. Okay, it gives you maybe a seasonal hat here. Give me a thumbs up, subscribe to my YouTube channel, and I'm going to see you next time. Bye now.